Welcome back. So now to our application questions, and they're still based on a series circuit. So the first question, we are supposed now to fill in the missing words in these questions that are given to us. So we have that now. A flow of electrons is known as. So what is a flow of electrons known as? So we know that when electrons flow from one terminal to the other terminal, that is known as your electric current. So the flow, that's electric current, E. So the flow of electrons is known as electric current. Then B, the units for the measurement of current are, we do know that current is measured through an ammeter, and the units for that ammeter is ampere, with the symbol A for short. Next question. A circuit in which there is only one path for the electrons to flow is called. So when electrons, or when an electric charge only has one path to follow, then that particular circuit is going to be known as a series circuit. Why? Because the components are going to be connected one after the other, so that means the current doesn't have any other pathway to follow, only just that one. So a circuit in which there is only one path for the current to follow is called a series circuit. So that's our series circuit. Next question. In a circuit, energy is provided by so in our electric circuit that has the resistors being our light bulbs, we have the ammeter, if we can have the ammeter, the conducting wires. There is also something that is connected to there that is going to supply energy to the whole entire electric circuit. That can either be a cell or a battery. Remember, if it's a cell, it's just one with just one positive terminal and one negative terminal. Should it be a battery, there's going to be more than one cell, so it can be 2 or 3 or even more than one cell. So in a circuit, energy is provided by we can either say it is provided by the cell, or we can say it's provided by the battery. Remember that this is now a combination of more than one of these. So the cell can still provide energy to the circuit, or a battery can still provide energy to the circuit. Now, the last question says, the measure of how much an electrical component opposes the flow of current is called. So remember, what opposes the flow of current? We do know that current flows from one terminal to the other terminal, passing through the wires and then passing through the light bulbs. Now, those light bulbs are acting as our resistors. Now, the function of a resistor, it is to resist the flow of current. So it does allow the current to pass through, but it doesn't make it easier for the current to pass through. So therefore, the measure of how much an electric component opposes the flow of current is called resistance. We now need to give one-word answer for the following statements. So a continuous path for electrical charge to flow. So what do we call a continuous path for the electric charge to flow? So that is called an electric circuit. So that is called an electric circuit. So it provides a continuous path for the electric charge to flow, because the electrical charge flows from one terminal through the wires, through the light bulbs, back to the other terminal, then to the other terminal. So it provides that continuous path for the electrical charge to flow. And then number 2, a device used to measure current. We said we measure current by using the ammeter. So the ammeter is used to measure the current, how much current we have in the circuit. And remember, in series, the current is going to remain the same at whichever point you choose to measure it from. Then number 3, negatively charged particles. So remember, Particles, we have 3 particles. We have an atom that is made up of 3 subatomic particles. We have the protons, which are positively charged and are found in the nucleus. We have the neutrons, which do not have any charge and still found in the nucleus. So those 2 particles, they give the mass of an electron. And then we have the mass of an atom, rather. And then we also have another particle, the subatomic particle, known as an electron, that is now found around the nucleus, forming an electron cloud. And it has a negative charge. So a negatively charged particle or negatively charged particles, those are going to be your electrons. Those are your electrons. And then the last question, the SI unit for electric current. So when we are measuring our current, what is going to be the unit for current? We know that it is going to be amperes, and then short for, so it's A, which is short for amperes. So our current is measured in amperes, and short with the shorthand of that, we just write our A. Now, on this question, we are supposed to draw a line from each circuit symbol below to the correct name. So we have this symbol that we need to match it to the correct name. We have another symbol there and another one and another. So we have 4 symbols that we need to match on each of those names. We do know that this is a wire that is disconnected. And once a wire is disconnected, it makes a switch. It can either be an open switch or a closed switch. It's a closed switch if the wires are connected to each other. There's no gap in between the wires. So therefore, that is going to be a switch. That goes with that. So we can write here switch. And then this one, we do know that when we are drawing an electric circuit, we have this particular symbol or this particular component, which is going to denote a light bulb. So that denotes a light bulb, which means this goes with that. So I can also write bulb there. And then this number 3, we have terminals, a positive terminal and a negative terminal. And we have more than one. Remember, if it's 1, it makes a cell. If it's more than 1, it makes a battery. So that means this is a battery. So it goes with that. I can write there that this is a battery. So this is also supposed to have an R there to show that this is a battery. So then the last one is the ammeter, because everything else is taken. So obviously the last one is an ammeter. That's a symbol for ammeter, which is A. I can also write there that this is our ammeter. So now, before going to the next part of this lesson, we're just going to quickly go for an ad break, and I will see you just after this.